Okay, let's look at some of the homework problems. In number 2 for 14.2, we have r of t equals t squared t. Okay, so x is t squared, y is t. That implies x equals y squared. And t is between 2 and 0, so y is between 2 and 0. So when we sketch it, we have to draw this pretty big. We're going to get a sideways parabola, and then they want to know what R1 is. That's 1, 1. So let's say that that's right there. That's R1. And R of 1.1 is 1.21, 1.1. So that's 1, 1. Then if we go a little bit over, this is going to be R of 1.1. Okay. And then I want to draw the subtraction, and that's going to be let's see, right there, that's R of 1.1 minus R of 1. Okay, so R prime of 1 is a tangent at that point. So this is R prime of 1, because that's the tangent vector. And you noticed how close that's going to be. Let's do this. R 1.1 minus R of 1 divided by 0.1 is the vector 2.1, 1. And if I draw that coming out of here, it's just going to be the same. Same as the red, but it's going to be longer. Okay, because the red, let me keep it purple, R of 1.1 minus R of 1 is 0.21, 0.1. So that's shorter. That's just this vector right here is 10 times the length of R, or 1.1 minus R1. 10 times as long. But they're pretty much, if you had a grid paper, you could see that R prime of 1 is pretty much the same as this vector here. Okay. And actually, let's go ahead and find R prime of 1. R prime of 1 is, okay, if you take the derivative and plug in 1, is 2, 1. So you can see how close this is to this in the length. They're almost the same length and same direction. Okay, number 6 says that R is e to the t, e to the minus t, x is e to the t y is 1 over e to the t, which is 1 over x. So the graph is 1 over x. R of 0 is 1, 1. R prime of t is the derivative of each one of those since they're differentiable. And R prime of 0 is 1 minus 1. So there's R of 0. 1 minus 1 is coming out that way. So if we draw it up here, you can see that it is a tangent vector. Number 10, R prime of t is just the derivative of each one of those. 18, I want to find the unit vector for the tangent vector, and that means I just divide it by its length. So first we have to find r prime. So we just take the derivative of each component. We'll plug in 1. And so the length of r prime of 1 is the square root of 2 squared plus 2 squared plus 1 squared, which is the square root of 9, which is 3. So the unit vector means it has length 1 of the tangent unit vector is 2/3, 2/3, 1/3. 26. I have this function for r of t, and I have a point that it goes through 0 to 1. So let's see when it goes through that. That's when ln t is 0, 2 squared of t is 2, and t squared is 1, and this all happens when t is 1. So that does go through that point. And I take the derivative, and at 1, the derivative is 1, 1, 2. So I want it through this point, parallel to r prime of 1. So I have, I'll just write it out I'll write it out as parametric equations. I have x equals 0 plus 1t, y equal 2 plus 1t, and z equal 1 plus 2t, or t, 2 plus t, and 1 plus 2t. Okay, 36. I'm just doing integration. Integrate each one separately. So the first one is going to be 2/3 t to the 3/2 from 1 to 4i. This one, we're going to have to use integration by parts. So let's let t, we'll pick t to be the derivative, we'll do it the quick way, and we're going to integrate e to the negative t, and we're going to multiply those. So that's going to be minus t e to the minus t minus e to the negative t. 1 to 4, j. And when we integrate 1 over t squared, that's t to the minus 2. So that's going to be minus 1 over t, 1 to 4. I don't know. Okay. Okay, so this is going to be 16/3 minus 2/3 I. This is going to be minus 4e to the minus t minus e to the negative 4. That's a 4 minus 1 j and minus 1/4 minus is a plus 1 k. So this can be 14/3 I minus 5e to the minus 4 plus 2e to the minus 1j plus 3/4 k. And I've integrated it. Okay, so I hope this helps you with some of your problems.